In this web clip, we will demonstrate how to use the Cresset Engine Broker to accelerate pharmacophore generation in Forge. In the example, we will look at some chemokine receptor inhibitors that are involved in the viral entry pathway for HIV, and as such, this means that there are potential therapeutic applications for the treatment of AIDS. CCR5 receptor is a GPCR, and like many of these receptors, crystallographic information can be scarce. FieldTemplater is a functionality that is built into Forge and allows for the calculation of binding mode hypotheses. To do a FieldTemplater experiment, we take a few known active compounds and create field-based templates that encapsulate the pharmacophore. Each compound is conformationally populated, then a pairwise alignment of each conformation of each molecule with each other molecule is done until a consensus alignment or alignments are found. As you can imagine, this can be extremely intensive computationally. To speed this up, we can connect Cresset applications to Field Engine resources to use distributed computing for Forge and Spark experiments. We do this with the Cresset Engine Broker. Now, we've always been able to do this type of distributed computing. However, there was quite a bit of setup that had to be done at the beginning. With the Cresset Engine Broker, little or no configuration is needed to enhance the speed of desktop virtual screening, FieldTemplater experiments, and bioisostere substitutions with many databases in Spark. To set up the Cresset Engine Broker, we need to tell the software where the additional computing resources are. So we go to Edit, Preferences, and under the Processing tab, we see we have a section for the Cresset Engine Broker. So here we enter the host name or the IP address of the computer which is running the Cresset Engine Broker. In my case, the additional resources are on CrestDisk on port 9000. Let's test the connection. So it's telling me that my connection is okay and that there are 134 field engines currently running and I can start up to 150. What this means is that our cluster is a little bit busy at the present moment. Let's press OK. In the FieldTemplater experiment, you can see that I have 5 molecules already loaded into the interface. These molecules are known CCR5 inhibitors. To start the experiment, I'm going to press Process. And you'll see in our options, we have options for the molecules that we brought in. We have our conformation hunting parameters. We have how we do our alignment, and as usual, we'll use 50% fields and 50% shape. And finally, how we do our templating. And we're going to set the minimum number of molecules per template at 4. Over on the right now, you'll see that I have the molecules already populated conformationally, and this will speed up the calculation. Let's press Go. So once the experiment begins running, you'll see that there are 4 processes that are ongoing, and these are the processors that are associated with my laptop. In a couple of moments, you'll see that the Cresset Engine Broker will kick in, and the resources that are available on the CrestDisk cluster will come online. And here they go. So now, in addition to the 4 local processors, I have the processors associated with the Cresset Engine Broker that are running on our cluster farm. Now, this experiment will take a little bit of time, so I will pause the recording and we'll come back when it finishes. The number of processors definitely influence how quickly an experiment runs. So now that the FieldTemplater experiment has finished, we see that we have approximately 30 binding mode hypotheses that we can examine and decide on which one we want to proceed with. Let's take the first one over to Forge, and what we'll do is compare the UK 427857 binding mode hypothesis with the crystal structure binding mode. So let's send this over to Forge. We'll import this to a new role. So now we have those 4 ligands from the template in Forge. What we want to do now is find the crystal structure that has this particular ligand, and I happen to know the PDB access code. So let's grab that structure. The structure is 4-MBS. Now this opens the protein editor, and in the protein editor, we'll choose the ligand as a reference, and we'll import the rest as a protein. There they are. So now before we do the alignment, we need to ensure that the ligands that are in there from the template are marked as aligned. And what this does is it tells the software that there is a conformation associated with those ligands. So now let's do our alignment of the 427857. We are not going to conformationally populate it, and we'll just do a standard alignment. This just takes a couple of seconds. And remember that we're not aligning on chemical structure, but rather on our field points using 50% fields and 50% shape. Give this a second. And there we go. Now, if we look at our alignment, we see that the structures are overlaid quite nicely. But to look closer, let's change the color of the reference. And I happen to like the color pink. Change this to pink. Okay. So now when we look at the overlay, we see that we've done a really good job of aligning the terminal group here. The amide's looking good. The phenyl group is looking good. The adamantane looks good. The only difference is in the alignment of the other terminal group, where we see that we have a bond that is rotated 180 degrees. Let's separate to take a closer look. So it's as simple as the hydrophobe field points are switched between the structures on that terminal group. Overall, the template is really good. Ultimately, the field point pattern is substantially conserved. And we've got an alignment score of 0.848, which is really good. So I'm quite happy with this binding mode hypothesis that we generated today. And in fact, if you were to do a Blaze experiment, a virtual screen using both of these particular field point patterns, the results would be substantially the same. I hope you've enjoyed this web clip where we've shown how to accelerate pharmacophore generation within Forge using the Cresset Engine Broker. If you would like some additional information about this product, please visit our website at cresset-group.com/products/forge or send an email to inquiries@cresset-group.com.